nth root of a complex number. We already did some part of the questions. Isn't it clear for you? That part is clear. The note what we have done in that class. Right. Then today we will start with the further argon diagram. Further argon diagram. Further argon diagrams, right? So when we are working about the argon diagram, initially we need to learn about the locus, or we call the loci of an argon diagram. Argon diagram. Then initially if you get, we have to learn about few variations of these complex moduluses, right? Then if you get some kind of a complex number somewhere like this, if this is z1 is equals to x1 plus iy1, and if you get z2 equals to x2 plus iy2. So in that case there is a simple definition. If you mark the two complex numbers over here and here, so this is, if you get z1, that is x1, this is sorry, if I just write it here, z1 equals to x1 plus iy1, and this is z2, that is x2 plus iy2. So in this case, if I just draw a line from here to here to here, that indicates you z1 minus z2, the complex number. That's the simplest idea where we can understand from this. So we should draw this. z2 minus z2, because starting from z2 to z1, right? The same format. If you just like the same thing what you learned in the vectors. If you want to travel from here to here, you have to go from here to here and can come up to over here. So that's a fact we have to understand for this. Like this. If you travel from here to here, go from here and it's come from here. So in that case, this is going backwards and this is minus z1. If you're going from this side, it should be positive z2. So it should be z2 minus z1. That's how it comes from. The next format where we can understand this means like this. If there is a complex number z minus z0, the modulus is equals to 8. This format indicates you it's a circle with center z0. It's a center z0 with radius a. With radius a. That's what we need to understand from that's a part or the loci or the locus of this complex representation. For example, if you get z minus, I will get it as z minus 2 plus 3i. The modulus is equals to 5. You get a picture like this. So initially we have to make them into a format of this method. Z minus Z0 modulus is equals to 8. So it brought into this format today. Okay, for this case what you can do is you can write Z minus, this is plus 2 minus 3i. Now see here, minus into 2 is minus 2, minus into minus 3i is plus 3i is equals to 5. So you can say what do you call that, some kind of a complex number with real part is 2. So around real axis there should be 2 units. Along imaginary axis there should be plus, sorry, 2 minus, so this is 3, sorry, it's just a minus 3, this side. Minus 3, it's not plus 2, so it should be here. This is 2 minus 3I. And what is the radius, sorry, what is the radius there? Radius should be 5. So you can say generally you have to understand that from here is 3, 5 means somewhere like this point, right? You have to draw and then get some kind of idea of what kind of radius is that. So it's just like a circle, somewhere like this. It's a circle. You are drawing a perfect radius just like that. You get this circle. That's an example for this problem. Then if you go ahead with another example like this. The next extension is Z plus I. Sorry, I'll just write Z minus I equals to 2. So if you get this, you can understand that whether this Z naught is how much here. Z naught is equal to I. And what is the radius? Radius is equal to 2. So therefore it's a circle. I means around imaginary axis 1 unit. So here imaginary axis and radius is how much? Radius should be 2. So it's a circle somewhere like this. Here this is 3 and this is it should be how much? Minus 1. Something it's not in the proper scale. It's a bit transfer. The next format where you can understand is like this. They mention Z minus Z1 modulus is equals to Z minus Z2 the modulus of it. What kind of a graph is this? That's what we need to understand as the next theory. So what we need to understand is this is the perpendicular bisector of Z1 and Z2. So Z1, Z2 the perpendicular bisector. So this is the perpendicular bisector of Z1, Z2. If you just draw the graph like this, this is the complex number Z1, let's suppose, and this is the complex number Z2. So you know that this is the line of Z1, Z2. Okay. Then, if you draw perpendicular bisector, just like this, it's a traveling through the midpoint of these two, it's perpendicular to that. So this is the path of Z minus Z1 the modulus equals to Z minus Z2 the modulus of. That's how it comes. Then, if you do example somewhere like this, you will get Z minus 2 plus 3I modulus is equals to Z minus 4 minus 2I. So, initially what you need to do is you have to work out this coordinate. So sorry, initially what we need to do is to form into z minus z not form into it. Then we calculate z minus 2 minus 3i. The modulus of it is equals to z minus 4 plus 2i. Okay, right. Then what you need to do is we can sketch this in a diagram. 2 minus 3i. Over here 2, over here 3. This is 2 minus 3i point. That is z1. Sorry, just keep like this. Nothing called z. Right. The next one is 4 plus 2y. 4 plus 2y. This is the point 4 plus 2y. Right. Then this is the line. So we need to get the perpendicular bisector for that. The perpendicular bisector is traveling through midpoint. It's just like visibly somewhere like this, right? Then this is the coordinate of z minus 2 plus 3i modulus is equals to z minus 4 minus 2i the modulus, right? Sometimes they want to find out the equation of this locus, equation of the locus. So you can say if you want to find the equation of the locus, how do you get this equation of this locus? So to get the equation of the locus, what you need to do is consider let z is equals to x plus iy. This is the general format of a complex number. Then we will replace x plus iy over here. X plus iy minus 2 plus 3i the modulus is equals to x plus iy minus 4 minus 2i. Then over here you can say x minus 2 plus I times of y plus 3. The modulus is equals to modulus x minus 4 plus I times of y minus 2, the modulus of it. Right. Then what you can get here is, just I'll write the answer over here today. So you can say the modulus of this bit. The modulus of this bit is x minus 2 whole thing squared plus y plus 3 whole thing squared, the square root of it. Modulus of a complex number. If the complex number is z is equals to x plus iy, we know that modulus of z is how much? X squared plus y squared, the square root of it here. This is equals to how much? You can say from the other part x minus 4 the squared plus y minus 2 squared, the square root of it. Since you have the both sides the square roots, you can square the both sides. There you can write x minus 2 squared plus y plus 3 squared is equals to x minus 4 squared plus y minus 2 squared. Right. So if you expand this bracket, you will be getting x squared minus 2x plus minus 4x plus 4 plus y squared plus 6y plus 9 equals to x squared minus 8x plus 16 plus y squared minus 4y plus 4. Now you can understand that you can cancel this x squared with x squared over here. This y squared with y squared over here. Then you can say it is minus 4x, I'll just simplify y terms first of all. Minus 4y, if you go to other side is plus 4y. Minus 1 go to other side is plus 4y. There is another 6y over here. Okay, then it will turn up to how much? 10y. This is turn up to 10y. Right. Then I will bring the constant terms to other side. Minus 4 go to other side is plus 4x. Minus 8x plus 4x is minus 4. Minus 4x. That's minus 4x. Constant terms. 4 plus 9 is 13. If you go to other side is minus 13. 16 minus 13 is plus 3. Plus 3 plus 4 is plus 7. Plus 7. Therefore, the final answer will come, I'll just write it here. 10y equals to minus 4x plus 7. Or you can say y equals to minus 4 over 10x plus 7 over 10. Or you can write 205 and 710 is the final answer. Now it's verified. You can understand that it's a graph with a negative gradient, obvious, and a positive intercept. Yes, you have some kind of clue where the answer is correct. Right? That's very good. Yes. Right. Then the next question, the situation is they mentioned given that Z satisfy. They have given Z satisfy Z minus 4 the modulus is equals to 5. Right. The first part of the question, sketch the laws. Sketch Loci. Part B, they can ask you the find the values satisfy Z minus 4 the modulus equals to 5 and imaginary of Z is equals to 0. Right. The next question is part 1. Part 2 is Z minus 4 is equals to 5 and real number of Z is equals to 0. Imaginary part is equals to 0, both conditions, and the real part is equals to 0, right? Then and the third one you can say equation of Z minus 4 equals to 5. The equation of the locus, you can say equation of locus. Right. Let's see how to do this question. Right. Initially what you need to do is we can draw the sketch. So you can say if you go ahead with A, here this is a circle with center 4. Center is 4 and radius is 5 there. Since the radius is 5, you can understand that it's traveling a circle somewhere like this, traveling through 9 and traveling through 1. Over here, then you can draw the circle somewhere like this. It will be perfect with the radius of 5. Then how do you get it? From here you can say Z naught is equals to 4 and R is equals to 5. With that you can get the equation of the circle. It's a circle. Just, I think my drawings are not that perfect. Okay. Then the part B, the question what they ask is today, Z is equals to, this one is a locus over here, Z minus 4 modulus equals 5 and imaginary is 0. That means imaginary axis is 0. That means they are referring to these 2 points. This is the line where the imaginary axis is 0. This is the real axis. That means you can get find the value. So you can say the value is 1. If you write it as a coordinate, values would be 1 and 9. Sorry, minus 1 and 9. So it should be minus 1 and 9. Then part B1. This is a part B1 answer. Then 2 answer. The points where this one where the real axis is 0. The real axis is 0. Real axis 0 means which 2 points? This point and this point. How do we verify this answer? That is the important point where we can understand. Then I will go ahead with the small construction. If I draw a line over here, this one also find the radius of the same circle. And we know that this length is how much? 4. If you apply the Pythagoras theorem, since it's a right angle triangle, this side is how much? 3. Therefore, this coordinate would be how much? This is 3i. Same dimension goes to over here. From here, if you get 3 inside, should be minus 3i. So the solutions are, values would be 3i and minus 3i. Those are the 2 solutions. Right. Then if you go ahead with the equation of the Loci, that is the important point. The equation of the Loci, I will just do it here, part 3. We know that we will get let Z is equals to x plus iy. If it is so, x plus iy minus 4 modulus is equals to 5. So this is x minus 4 plus iy, the modulus is equals to 5. So that is x minus 4 squared plus y squared, the square root is equals to 5. The modulus of this. So if you remove the square roots from both sides, return up to x minus 4 squared plus y squared equals to 25. You square the both sides. If you square, the square root goes here and 5 squared is 25. So it will turn up to x squared minus 8x plus 16. Go to the other side is minus 16. Turn up to 9 plus y squared. It's a circle. It's an equation of a circle. So you can simply understand from this diagram. That's a way of getting it. Yes. In this exercise, yes, right. The next question in this exercise is they have given there's a complex number is satisfied. Z minus 5 minus 3i, the modulus is equals to 3. Part A, sketch the Loci. Cartesian equation. Part B is Cartesian equation of Loci. Yeah. Then part C, find the maximum value of RZ. Right, okay. Let's see how to do this question today. Right. Then you can understand that it's a, if you sketch the diagram, you can say the center. So if you just work out this question, you can see this is if you write this one, this is Z minus 5 plus 3i modulus is equals to 3. Right. The other center is 5, 3. 5 and 3. It's somewhere over here. Right. Center 5, 3. 5, 3. And the radius is 3 today. If when the center is 3, so you can understand that it's a circle with radius 3. So this side also 3 to take. So it's a some kind of a circle like this. Right. It is a part of it. Right. Then part B, they ask for the Cartesian equation. Then how with the usual format, we will get x equals to I by z equals to I by. Then you can say x plus I by minus 5 minus 3i, the modulus is equal to 3. So you can say x minus 5 whole thing square plus y minus 3i, sorry, modulus is equal to 3 the square root of it. So this turn up to x minus 5 whole thing square plus y minus 3 whole thing square is equal to 3 squared is the equation of the circle with center 5 and 3 with radius 3, right? Then they ask about children. This is the way. The maximum and the maximum value of argand is Z. Z means this is the Z is on this Loci or on this circumference. So you can see if you get some kind of a point over here, if the Z is over here, the angle is how much? 0. If it is over here, angle is this big. Like that, if you travel over here, you can see the angle increases. So if you just use some kind of a long stuff, it's like this. When it's moving, the angle increases. After that, what happens? After one point, angle again decreases when you traveling from here. Just right, if I get a small sketch over here, the circle is like this. Over here there is a, what we call that arc is in this way. It's here, like that. It's here. It's here. After that, when you come up to the sum point here, again it decreases. Therefore, the point with the maximum arc is this. This is the point. The line drawing from the tangent from this point is the where you get the maximum argument. So you can see, I just use a different color. Second row. Okay. Then we will draw tangent from this point. We know that if you draw a tangent, it's perpendicular to here. So you can do this construction. So this is a maximum argument. How do you find it? That's an important point. Then we know that here also it's perpendicular. These two are perpendicular. So I need to find the angle over here. Then how do you suppose to find it? I just make a small construction like this. You can see it's a triangle somewhere like this. This coordinate is 0, 0 and this coordinate is 5, 3, and here this length is, radius is 3. It's a right angle triangle. Right. Then if you apply the Pythagoras theorem, you can say this length, x. X is equals to 5 minus 0 squared plus 3 minus 0 squared, the square root of it. 25 plus 9 is 34. 34, the square root of 34. With that you can find the length over here. I just mark this one in as y. So you can say x squared is equals to 3 squared plus y squared. Other than that, no need of doing it because we know the length of it. Here the length is root 34. Then this length is how much? 3. Then I can find the angle over here. So you can say this is the opposite and this is the hypotenuse. Sin theta is equal to 3 over root 34. Therefore, theta is equal to how much? Sin inverse of 3 over root 34. Then that is the only this bit. This bit also the same because we know that if you draw a tangent from one point to the circle, both the angles perform the same way. So therefore, what will be the total angle? Then you can say R Z maximum would be how much? 2 times of value of this bit. You can find this value and get this answer. Then if you work out here, this will be 0.54 and twice of 0.54 is 1.08. That is how it comes, right? Then let's go to the next question. Right. Now the next question they have given. There's a complex number Z which satisfied Z minus 12 minus 5i. 12 minus 5i, the modulus is equals to 3. They ask about the maximum and minimum value of Z. Part A, maximum and maximum. Part B of Z. Part B, minimum of modulus of Z, length of Z. The maximum length of Z and minimum length of Z. Right, okay. Then C, they ask about arc Z maximum, the maximum argument, and this one is arc Z minimum. Right. So initially what you need to understand is we have to see whether what kind of a shape is this. So it's a circle. So if you just work out of it, you can say that this is Z minus 12 plus 5i. The modulus is equals to 3. Right. So you can see it's a circle with center 12, 5i. 12 and this is 5. So somewhere here. Right. Then it's a circle with radius how much? It's a circle with radius 3. Radius is 3. Radius is 3. Somewhere like this is 3. Right. Then what you need to get here is to take the maximum value of the argument of z. That means you can see if you drawing line from here, the argument is this length. Like that it varies to, that means like when it's moving from point here, just like this circle is here. So if you get this point, the argument is this length. If you get a point over here, its argument of this. This point is this length. Here also this length and this length. And like that it length varies from point to point where it's on the locus. It is on the circumference of the circle. Then if you analyze this, you get a maximum length over here. The line drawing from here, if you just do this, you can see it's a length. The maximum is over here. This is Z max. Modulus of Z max is here. Right? This is the point with what? Z modulus of Z minimum. Then you can see if you just draw construction over here, this length is 12. And this length is how much? This is 5 from here to here. And this length is 12. Right. Then we know that if by the Pythagoras theorem, this length is how much? From here to here itself how much? 30. Up to here. Right. Then we know that the Z modulus of Z maximum, the first part of it, part A, maximum of, so you can say modulus of Z maximum is from here to here, the length is 13, another 3 is added to that. So that is 16. That came from 13 plus 3. It's 16. Right. B is modulus of Z minimum. How do you get it? From 13 minus 3, that is how much? 10. That's how it comes, right? Okay. Then we need to worry about how to find the angle. The minimum and the maximum argument of this angle, right? Okay. Yeah, initially just copy down this. Then after that I can erase it. Then if you need to find the